Okay, let's start. We've only got a few minutes, so let's whiz through this. So I'm John Payne, work for a company called InterSystems. We have a stand upstairs if you hadn't noticed it yet. And what I'm going to do for the next 15 minutes is briefly talk about a new platform that we have that's oriented towards treating data differently. It's all about handling transactions, it's all about handling big data, it's all about doing analytics on a single platform with a single copy of the data. So a little bit of background as to who we are. We've been in the data platform business for about 40 years. Lots of examples of what we do. This is one that you may have come across. Anybody recognize this picture? Oh, dear me. Okay, so this is the latest image of the Milky Way, come from the Gaia project. So this is a European Space Agency-based project where they're mapping the galaxy in a lot more detail than has been done to date. It's producing lots of interesting scientific breakthroughs, and they're using our data platform to process the data that comes down from the Gaia satellite. It's an unusual approach because they're managing to process the data in real time. Normally, these sorts of scientific experiments produce vast amounts of data that take years and years and years to get processed. Here, every 30 days, the Gaia satellite whirls around, gets closer to the Earth, dumps 30 days worth of data down, and then goes back up and does another 30 days of observations. They're processing that data in real time using our platform. Anyway, so let's move on. So most applications today, in fact, pretty much all applications today, are data rich. And what that means is they need to do a lot of different things with data from a number of different perspectives. One of the key elements of applications is that they need to be simple. Earlier on today in the introductory sessions, there was a number of discussions from the speakers about low code, writing minimum amounts of code. And to me, simplicity really is key when you're building applications. So writing the minimum amounts of code, and also I suggest keeping an approach which provides for low data. So the minimum amounts of occurrences of data, keep data once and reuse it for multiple different reasons. Process that data in real time. Interoperate with other systems that are around, or other applications, or other entities, or other data sources. Be open in the way in which you can do analytics. So lots of different ways of handling and processing data in different analytical frameworks. Vast scalability is needed these days. Obviously, everyone goes in looking at different cloud-based scaling solutions, but there are other different ways to scale, and we talk about some of those. And then finally, obviously, cloud deployment, on-premise deployment, hybrid deployment. These are all features of modern applications today. Now, what we've done with the InterSystems Iris Data Platform, which is this new product that we've literally just introduced, is combined all these features into a single platform, which means that you can build out these complex solutions with a minimum amount of code, a minimum amount of data redundancies very rapidly. Okay, so let's talk a little bit about some of the concepts a bit more detailed. So HTAP, Hybrid Transactional Analytical Processing. So this really is the old worlds of OLTP, OLAP. It's the ability to handle transactional processing and analytics concurrently on the same data as it's moving in through the platform. Scalable in a vast number of different dimensions. So you might scale the data across multiple CPUs, across multiple physical or logical entities. You might scale your business logic. You might scale the communications. You might scale cache. There's lots of different scalability solutions with built-in durability. Now, this is quite important. It's a bit of a dirty word in the database world in terms of real durability of data. But if you look at what that really means, typically if you're looking in the in-memory world, which is where we start, you commit a transaction and that gets done within less than a microsecond, or certainly from within our platform. A transaction is completed in less than a microsecond. That becomes durable on disk using, well, the standard sort of non-volatile
memory storage, commodity flash memory that's available today. That becomes durable on disk in less than 20 microseconds, and that's predicated by the speed with which the actual storage pipeline can handle that. And then lots of other stuff goes on underneath or after that when you're looking at a durability model. But that's really about as fast as you can do it with using commodity hardware. And certainly that becomes very simple with our platform. Now, looking at those earlier characteristics, interoperability within the single platform. So this is service-based and microservice-based integration, business process orchestration, the ability to construct and manage processes, activities, short-running, long-running, system-based, person-based, across the whole environment from a single IDE on a single platform. This is all coming down to the idea that we can do things simply and quickly. Open analytics, so fast data analytics. What I mean by that is analytics on fast-moving data as it's coming through the platform. So one of the features of InterSystems Iris is we can consume data very rapidly. So you could have a single process streaming in 100,000, 200,000 data points a second, and that data can be combined with other data that's already resident in the platform or transactions coming in from other places, and you can do analytics on that data at that velocity as it's happening. We can also plug into the big data framework, so we have a very streamlined Spark connector. Is anybody using Apache Spark as a basis for analytics? A couple of you. Okay, so Spark is obviously this open framework where a lot of data scientists predominantly build models, analyze, you plug your Hadoop cluster into the bottom end of a Spark framework. What we can do is connect into a Spark framework from InterSystems Iris and use that as a basis for developing predictive models for doing machine learning. What we can then do is export the predictive models out of the Spark framework as PMML, load that into InterSystems Iris, and then run that close to the data. What that means is that as you're doing transactional data, as you're bringing in fast-moving data, you can be doing predictive modeling, you can be doing the real-time analytics as part of an operational transactional system, as part of an operational transactional environment. We also have the ability to manage unstructured data, do analytics on text as it flows through the system as well. So in the Spark world, this is a UEMA pipeline, basically unstructured data management. So again, it's all part of the same platform. The data has one copy. Scalability, I touched on this a little bit. There's a number of different ways to scale the solution or to scale the InterSystems Iris platform. Vertically, massive parallelization, so taking advantage of very large numbers of cores. Horizontally, you can scale in different ways, scaling out a distributed application cache, so scaling out the support for massively growing numbers of users running business logic, and then scaling out a partition data cache and transparently moving information around this network of nodes in order to facilitate things like joins between data or caching data at the fringes intelligently, which means that you don't have to transport the data across the network to satisfy a query or to fulfill a transaction. Gives you massively improved performance. We have a couple of examples I'll just touch on. First one's from an investment bank. They did some benchmarks, and actually what they did was they collapsed a transactional processing environment, a staging data mart and a data warehouse onto the InterSystems Iris platform. So they replaced 3 different data platforms. The hardware was much cheaper. They had significantly improved throughput, and it was much more reliable, and they serviced real-time analytics onto the trader's desk, as opposed to analytics happening after trades were done. So them taking complex predictive modeling or complex financial modeling out of the middle office, putting it into real time on the trader's desk before trades were actually actioned. So it made a big difference to their risk management. Another example, again in financial services, where we've got an asset management organisation repricing large quantities of financial indices in real time as data's moving through. And we've done there's a benchmark that's being done and independently run by a company called ESG. I'll talk about that in a little bit. But fundamentally, they found that InterSystems Iris was much more performant. So the idea behind this platform which combines all these characteristics is it gives you a low code and a low data way of deploying applications and evolving applications. So the minimum of code you need to write, a minimum number of occurrences of data, minimum number of times that you have to transform data and move it into a different environment to perform the sort of analytics and queries that you need to in a modern application. Okay, so let's just go into this benchmark in a little bit more detail. It was run by the Enterprise Strategy Group. The benchmark InterSystems Iris against 3 other different platforms. One was an existing in-house relational database. One was a columnar database, and the other one was a pure in-memory solution. Interestingly enough, the columnar database and the relational database ended up having to give it about twice more physical resources than gave Iris, and the in-memory solution ended up with, well, let's call it lots more resources. One of the first things that ESG found out was that they, in order to be able to do the queries reasonably, they had to limit the amount of data that they were loading into the test beds for the other databases. Whereas with Iris, they were much less limited. In fact, the limitation on the data to load into Iris was based on the data source and the ability for the data warehouse, which had the older data, to deliver that data. So the other solutions we had about 20 days data. In Iris, we had about 140 days worth of data. And what we saw that reliably and predictably, query times coming back from the different platforms were noticeably different. The blue line, which is Iris, is pretty much at the bottom, and then we had the in-memory solution, relational engine, and the columnar database. And as we move through the different complexities of query, increasing the complexity, then we can see that the response times for Iris were pretty flat. The in-memory solution performed reasonably well. The others sort of was starting to get into real trouble. There's a lot more data behind this, but the underlying message of this is that with InterSystems Iris, we can handle complex data much more rapidly, much more reliably, on a lot less kit. And really, it's all about being able to take action on information that's flowing through your application space, being able to make more intelligent decisions faster, based on systems that are easier to build, easier to evolve. And that's really a message that I'd like to get across today, this sort of low code, low data. And we've got information about a couple of benchmarks and studies that are done that are on our stand, which you're welcome to come along and have copies on. One is the ESG Labs Performance Benchmark, which I just outlined, and there's another by a company called Neuralytics, which is looking at low code and building an app on the InterSystems data platform as a basis versus a complete sort of open source stack solution. Okay, I realise that I now have approximately 30 seconds left. So if anybody would like to ask a question, it's probably better to do that once I've unplugged, and we can talk either outside or wherever, because I suspect there's another session going to be coming along quite shortly. But hopefully you found that interesting anyway. Thank you.